All right, so for lesson 3.2, if you did pretty well with 2.8, you should do fabulous with this lesson because we are going to basically do the same thing of graphing inequalities, but this time with systems. So we're just going to add one more in there and basically see where they overlap. So should be fairly easy. Let's take a look at, here is this graph on the left, here is this graph on the right, and if we put the two graphs together, we can see where they shade the shading overlaps, and that is our solution region, which is basically what we're looking for. So let's quickly review. If we are solid and above, so we would be greater than or equal to. If we're solid and below, then we would be less than or equal to. If we're dotted, then we're just above, greater than, no line, and less than for below and dotted. All right, so let's flip to page 12 here, and we are going to graph our first system of inequalities. So if you've got two different colors, that would actually be very beneficial to you. Pencil could be one, and then just some other, try not to use pen, but some other color, either pencil or highlighter or something, but you don't want to definitely use something that's too permanent and accidentally make a mistake. So I'm going to use pen because, you know, I just make, well, I do make some mistakes. All right, so let's do green with this one, and then I'm going to do orange with this one so you can kind of see how the two are going to look. So green is going to be starting at 4, moving down 2 over 1, down 2 over 1, and I'm just going to kind of continue that. Again, I like lots of points because that's going to help me draw an accurate line. This one's going to be a solid line because it's less than or equal to. So we want to draw a solid line all the way through all those points there. And arrows, whoops, making sure you are using that straight edge. Now we are shading, again, y is less. So we want very lightly to shade everything less than this line below the escalator. So I'm going to very lightly shade in green this region. All right. Now, I'm going to use orange for my second line. -3 is the starting point. Again, if you shade it too hard, it's dark, it's hard to see where you're graphing your second one, but so keep it light, up 1 over 1, up 1 over 1, up 1 over 1. And this one's dotted because we are greater than and there's no line underneath there. So make sure that this is a dotted line. Okay, now for this line, I'm going to shade everything above. So again, we're just looking at this line. So I'm going to shade everything on this side or everything on this side. Well, I want above. So where would I be riding the escalator? I would be riding it up this way. So I want everything above this side of the line there. So I'm going to go ahead and shade, again, kind of lightly, everything above. Now we can see the overlap. So I'm going to go ahead and kind of highlight this area a little bit darker so you can see it right here. This region where it's overlapping, that is your solution region. And what you can do is once you've got that, you can test a point in that region. When I see 0 zeros in there, in that double shaded region, so we could plug in 0 and test to see if that truly works. So 0 less than or equal to 4 and 0 greater than -3. Yes and yes. So 0, 0 does work. So we did get the correct region shaded. All right, let's do one more, and then I'm going to have you try some on your own. Let's take a look. I think I want to switch to pink and blue for the baby. All right, so we're going to start at 2, and we're going to go up 1, 2, 3 over 2, up 1, 2, 3 over 2, and solid line. and we're shading everything when it says y is greater. We're going to shade everything above where you would ride that escalator. So right here. Okay. Now, the next one is going to be a vertical line. We're going to go through the x-axis. Here's my x-axis at 3. So going to the x-axis at 3, and I want a vertical line going through that axis. And this one is going to be a dotted line because we are just going to be less than. There's my dotted line. And I want less than, so that means I'm going to shade everything to the left. Think of the right side as greater and the left side as less than. And you can see that my region that is overlapping here is right here. Kind of double shade it with some green. Make it a little darker so you can see it. That's my solution region right there. And then you can test a point. So as you can see, 0, 0 is not in this dark region. So you'd have to pick something in this region to test. But I know I'm right. So I'm going to move on to 3 and 4. And I want you to try these on your own. Number 3. Try that one first and then check, and then I'm going to help you change number 4, and then I want you to graph it. So pause, check number 3 when you are ready. All right, so check number 3, that you graphed that correctly. Double check solid line here for horizontal through -1, dotted line starting at 2 down 3/1, and that you have this upper left region as your shaded the darkest there. And then you could test 0, 0 because it is in that spot and use that one. And yep, 0, 0 works. All right, so let's take a look at number 4, changing that into slope-intercept form. So our first step is going to be subtract x, so y is greater than -x plus 5. And then for this one, we're going to add 2x to both sides. So y is less than or equal to 2x plus 2. So go ahead and graph both those, shade, and check when you're ready. All right, so should look like this, dotted line going down for our negative slope there, and then solid line positive slope, and then this should be upper kind of right region should be your shaded the darkest. All right, so let's take a look at page 12. We are going to write some systems, and then we'll do one word problem to finish us up. So for this one, it helps to kind of put your points, getting some points on there where you can see, and then we have, so our starting point here is going to be 3. So I'm going to go ahead and put my 3, and then it's positive. This intercept's -2, so I can go ahead and put that intercept in there. I know I'm going to have an x, and then I know I'm going to have a y, and then I know I need a slope. So let's go ahead and find our slopes, and then we'll put in our inequalities. So the slope for this one, it looks like we are going up. Well, I've got a point down here, so let's count up. 1, 2, 3, 4, 5 over 1. So that is a positive slope of 5. It's kind of hard to tell when they're more dashed. This one, it looks like we are going up 1 over 1, up 1 over 1, up 1 over 1. So that one would just be a slope of 1, which I don't need to put anything there. All right, so for our dotted lines, we know we're just going to have an inequality with no line underneath it. But let's look at the shading. So for this line that was starting at 3 with a slope of 5, looks like we're shading above the escalator where we would ride. So that means we want this to be greater than. So we shade above. And let me double check my slope here. 1, 2, 3, 4, 5. Yep. Okay. For this line, it looks like nothing is shaded where the mechanics would be. So that means we're also above this line, even though it's just a little bit that we can see there, but we are where we would ride the escalator, so we're above this line as well. Let's do another one. Again, let's fill in some points here. We've got a point there that we're touching. Definitely have a point here. And this solid line's pretty easy to tell. It's just that dotted line. But we have at least 2. So we know our starting point's up here at 3. For the solid line, it looks like we're intercepting here at -2 for that y-intercept. Let's fill in our y's. And now we need our slopes. So we'll put our x's in there. Now let's fill in our slopes. This one's a negative because we're going down 1, 2, 3, 4 over 1. So that's a -4 for a slope. The solid line, it looks like we're going up 1 over 1, up 1 over 1, up 1 over 1. So again, a slope of 1. We don't need to put the 1 there though. Solid line for this one, this second one. So we know we're going to have our little line underneath our inequality. Let's look at the shading. For the dashed line, which is the top line, it looks like we're where we would ride the escalator. So we'd ride the escalator down. Again, the mechanics would be back here. So that means we are greater. For this solid line though, it looks like we're having all the shading where the mechanics of the escalator would be, which would be below the solid line. So we want to make it a less than for that second one. Y is less than, and then or equal to because it's solid. All right, so a little tricky. I think you can do it though. Try those next 2 on your own. Check your answer when you're ready. All right, check and see how you did, both with the inequalities, with the slopes, with the intercepts. Pause if you need a little more time, or rewind if I change it too quickly. Make sure to write any questions that you have either off to the side or at the bottom. All right, we're going to take a look at the last example here. Lauren wants to paint more than 70 plates for an art show. It costs her $50 to be in the show, plus $2 for every red plate and $3 for every gold plate. She wants to spend no more than $215. Let's write and graph a system. All right, so we have our plates. Let's do X and Y. We know that has to be less than 70 because that's 70 plates for the art show. And then for money, we're going to put all the money together. So for 2 X's, that's going to be our $2 for the red, plus, well, we have this $50 we need to put in there because that's just going to cost her $50 to be in it. And then $3 for every gold, so 3Y. And that has to be less than $215. Again, we put all the money together in an inequality. No more than. So it could be equal to $215, but it has to be less than. So now we've got 2 equations we can go ahead and graph. We do need to get them in slope-intercept form though. So let's take a look at this first one up here. That's easy, just subtract the x to get it to the other side. So that would be y is less than or equal to -x plus 70. So we could go ahead and graph that one here in just a second. And then this one, we need to get the y alone. So let's subtract 2x and 50. And I'm going to do it at the same time, but you can take it one step at a time. 3y less than or equal to -2x. 215 minus 50. We want to actually do that, 165. And then divide by 3. So y is less than or equal to -2/3 x plus 55. All right, so go ahead and graph. We're going to go up by 5s and on both directions, and I'm going to go ahead and graph that and then show you what it should look like. All right, so graphing by 5s, graphing both those lines, this line down here and this line up here. And the shaded region is the region that's the combination of the different plates that she could do. So the X's were the red, and up here were the gold. So any combination, so anything in that shaded region would be the combination of both that she could do. All right, make sure to write any questions that you have at the bottom and be sure to ask those in class.